Today, we look at the second method that we use in linear programming, which is called Simplex method. It's called Simplex method. So I want us to look for a question. We solve it. So I want us to solve this question of September 2021. Question of September 2021. Question number 2B. Question number 2B. Question number 2B. So the question says, Zachem Limited produces two products, namely alcohol and xenon. The products pass through three departments, namely assembly, finishing, and packaging. There is a maximum of 200 hours in each of the assembly and finishing departments. In addition, a maximum of 400 hours of packaging are available for packing, alcohol, and xenon. The table below shows the number of hours required per unit of each product. So we are given that each unit of alcohol and xenon gives a profit contribution of shillings 3,000 and shillings 2,000 respectively. Now formulate a linear programming model to solve the above problem. So in doing that, the very first thing that we need to do is called formulation. The very first thing that we need to do is called formulation. Now, in the formulation, we say you begin by saying let X represent units of alcohol, produced and sold. Produced and sold. Produced and sold. Y to represent units of xenon, produced and sold. Xenon produced and sold. Then objective function. Objective function will be to maximize Z, which is equal to xenon alcohol has 3,000, so 3,000 X plus 2,000 Y. Now this is subject to, if you look at the assembly, it is 2X plus 3Y is less than or equal to, the assembly has 200 hours. These are assembly hours. Assembly hours. I have 4X plus 2Y is less than or equal to 200. This is finishing hours. finishing hours. Then 5x plus the 3y less than or equal to 400. And this is packaging hours. Packaging hours. And then I told you what you need to do is to come here again and say xy is greater than or equal to 0. And this is called non-negativity. So that is the first step of the formulation. Or that is the formulation. Now, once you have formulated that way, go to the next step, which is called changing inequalities. Changing inequalities into equalities. Changing inequalities to equalities. So what we do here, we introduce the slack variables. So we say let S1 to be equal to slack variable for assembly hours. Slack variable for assembly hours. S2 to be slack variable for finishing hours. S3 to be the slack variable for packaging hours. Then, now the slack variables are introduced for every resource that we have. You can see we have 3 resources. That's why we have used 3 S's. We have 3 resources. That is why we have used 3 S's. Now, when you say then, you now bring the objective function. Then, objective function. So the objective function, you just bring this one the way it is to maximize z in equal to 3000x plus 2000y plus you now bring these s's and they all come with zeros. They all come with contributions of zeros. So S1 plus 0 S2 plus 0 S3. So that is how they come in. Now this is subject to, you now bring this one, 2x plus 3y. Now you introduce the first s, you bring the first s, so plus s1 equals to 200. Equals to 200. You bring this other one, 4x plus 2y plus s2 is equals to 200. Is equals to 200. And then 5x plus 3y plus S3 is equals to 400. So that is how we change the inequalities. This is how we change the inequalities. So after you have changed the inequalities, after you have changed the inequalities. We now draw something that is called initial simplex table, and I want to have this so that I get enough space. Allow me to grab this. I hope you have written the zeros so that I don't struggle with the space after that point. So what we are doing now, we are drawing a table called initial simplex table. So draw this initial simplex table. And this initial simplex table, it starts with a column we call C there, followed by another one we call basis. Another one we call basis. Now this one for basis, we put the slack variables. So there is S1, S2, S3. And then there are other rows that are there, CJ, ZJ, and DJ. So these three depend on how many tracks you have. Now here, this is X, this is Y. So here we are putting the values that are in this objective function. XY, S1, S2, S3. Then there is another one we call BI. Then the space that is left there, this one we call it ratio. The space that we shall work out. So once you have drawn up that point, let me know, type yes. You speak. Audrey, are you at that point?
Yes.
Okay, good. So let's now start recording the values. This column, see here, we record the coefficients of the S's here. The coefficients of the S's, which are the contribution margins, they were zeros. So we record zeros that way. Then we come to these functions here. Where there is S1, you can see X is 2, Y is 3, and S is 1. So we are going to record 2, we record 3 there, then S1 is 1, then this is 0 because we don't have them, and this is 200. We don't have S1, S2 and S3. When we come to this one, where we have S2, we will have 4 here. We will have 2 here. We don't have S1 there, but we have S2. We don't have S3, and the total is 200. The total is 200. Then we come to this one. It is 5, 3, 0, 0, 1, and 400. In 400. Then from there, the CJ, we record the values that are here. So this one is 3,000. This is 2,000. Then these are zeros. These are zeros. Those are zeros. We are recording the coefficients in the objective function. Then for ZJ, in the initial table, we always put zeros. In the initial table, we always put zeros. Then when it comes to DJ, you should note that DJ is given as CJ minus ZJ. CJ minus ZJ. So if we do so, this will be 3,000. This will be 2,000. This is 0, this is 0, this is 0, and that is 0. Then you check whether there are positive values. You check whether there are positive values here. If there are positive values, it means that your table is not optimal. And therefore, you need to create another table. So for us to do that, we identify the highest DJ. So you circle that. That is the highest. And then you say this one, where the highest DJ has been found, it is called key column. It is called key column. Where you have found the highest DJ, that column is called key column. Now, the value at the title of the key column, the value at the title of the key column, this one here, is called incoming variable. Is called incoming variable. Is called incoming variable. Then what you do from there, you take these values here, you divide by the corresponding values in the key column. Like now, this one I will say 200, you divide by 2, that gives me 100. 200, you divide by 4, that gives me 50. Then 400, you divide by 5, that gives us 80. So in getting the ratios, we are taking these PI, the values there, we divide by these 3 values. After you have done that, you take the highest, the lowest. You take the lowest value. Now, where you have gotten that, that row is called key row. That row is called key row, where you have identified the smallest. Now, the element or the item at the intersection of the key row and the key column is called key element, this one. So that 4 here is called key element. Is called key element. The element at the intersection of the key column and the key row. Then these items here, this item, which is that the title of the key row, this one, is called outgoing variable. Is called outgoing variable. That item at the title there is called outgoing variable. So once you have done that, it is time now to draw the next table. It's time to draw the next table. In the same design. So we are now drawing, second Simplex table. Second Simplex table. So in this second Simplex table, our column C still remains. Our column C still remains. Then these others still remain. So I have I have basis first. I have basis. Followed by X. Followed by Y. Followed by S1. Followed by S2. Followed by S3. Followed by BI, and then in case there will be need, I will have ratio. We'll have ratio. Have you finished drawing? Have you finished?
Yes.
Okay. So if that is okay, then we come back here. You see, this one was called that main S1. So we just fill it there, S1. Then this one was called outgoing. It is going to be replaced by the incoming. So instead of S2 now we write X. The S3 was not affected. Then CJ not affected, ZJ not affected, and VJ as well not affected. You record now the contribution margins of these items. So S1 has 0. X has a contribution margin of 3,000. And S3 has 0. As 0. So you now come here to the row X here. And you divide all these values here by the key element. So this one will be 4 divided by 4, that will give us 1. 2 divided by 4, that will give us 0.5. 0 divided by 4, that will be 0. 1 divided by 4, that will be 0.25. 0 divided by 4, 0. 200 divided by 4, it is 50. So we have divided these values in the key row using the key elements. Using the key elements. Now, there is a formula that we use. So down there, you write workings. Workings. So in the workings, I'm going to have, we are working now, tunataka kujaza S1. So we will have odd row S1 value, odd row S1 value minus new row value, times balancing figure times balancing figure, we will get new row S1 value is equals to new row S1 value. So what we do, we first of all take the odd row S1 values. This one, the S1. We have 2 followed by 3, followed by 1. There is a 0, and a 200. Those are the values in the odd row S1. Then these ones are the ones we are calling the new row, these ones. So we will say minus. You take 1, 0.5, 0, 0.25, 0, and 50. Then you say times. Balancing figure. Now, balancing figure balancing figure is the value at the intersection of the key column, the value at the intersection of the key column and the odd row that you're dealing with. That too is the balancing figure. So I put it here this way, it remains. Then I will say equals. Then I will say equals. Now, you take these values as they are and you put them in the calc. So I will say 2 minus 1 times 2 equals 0. I have 3 minus 0.5 times 2 equals 2. 1 minus 0 times 2 equals 1. 0 minus 0.25 times 2 is negative 0.5. 0 minus 0 times 2 is 0. 200 minus 50 times 2 is 100. So those values, we record them here now. Those values, we record them here. So this is 0, this is 2, this is 1, this is minus 0.5, this is 0, and that is the 100. That is 100. If we have done that, tukuje sasa kutafikiria S3. So we will say odd row S3 value, alafu hapa new row S3 value. So the new row still remains. So when I come to the odd row, I will have 5 here. I have 3, I have 2 zeros followed by 1, followed by 400. And the balancing figure is this 5, the value at the intersection of the key column and the key row. So this is 5, 5, 5, 5, 5, 5. So if I start working, 5 minus 1 times 5, 0. 3 minus 0.5 times 5 is 0.5. 0 minus 0 times 5 is 0. 0 minus 0.25 times 5 is negative 1.25. 1 minus 0 times 5 is 1. 400 minus 50 times 5 is 150. So those values, we record them here. 0, 0.5, 0, 31.25, 1, and 150. Are you up to that point, Audrey?
Yes.
Good. So CJ now, CJ does not change. So 3,000, we have 2,000, 0, 0, 0, 0. So we are still doing the workings. We are still doing the workings. So what happens now when you come to ZJ? you can say Z1. You take these values that are here in column C, you multiply with the corresponding values where your Z is. So the first one will be 0 times 0 plus 3000 times 1 plus 0 times 0. And the answer is 3000. So that 3000 inawekwa hapa. When you come to Z2, it will be 0 times 2 plus 3000 times 0.5 plus 0 times 0.5. That gives us 1500. So unaweka 1500 hapo. Z3 is 0 times 1 plus 3000 times 0 plus 0 times 0, and the whole of that is 0. Z4 is 0 times negative 0.5 plus 3000 times 0.25 plus 0 times negative 1.25, and this should be 750. Naiweka hapo 750. Halafu Z5 will be 0 times 0 plus 3000 times 0 plus 0 times 1. All these are zeros. And the last one, Z6, will be 0 times 100 plus 3000 times 50 plus 0 times 150. This is 150,000. So your 150,000 will hapa. That is 150,000. Those are workings for now for DJ, remember here we had said it is CJ minus ZJ. So 3000 minus 3000, that is 0. This is 500. This is 0. This is negative 750. This is 0. This is negative 150,000. So I told you what we do next now is confirm whether we have some positives. And you can see we still have a positive. So that means our table is not yet okay. So if it's not okay, we need to draw another table. Let's draw the third table down there. So now we are drawing what we are calling the third simplex table. Third simplex table. So again, we begin with our column C. So column C is followed by basis. And basis, I've told you, before we do the basis, let me divide x here. Y is 1, 2. Oh, my space. So this is x, this is y, this is S1, S2, S3. I'm hoping this is the last table. So I've not created space for ratio, but in case we need, they will inside. So, because I don't have space to write, and the same concept applies, I'm just going to explain. It is the same thing like we had with the other one. So this one becomes the key column because it's the highest. It's the key column. And this value here is the outgoing. Sorry, the incoming is the incoming. So once you know the incoming and the key column, tumesema you divide now these values here with the values here. So we start. Tumesema 100 divided by 2 is giving me 50. 100 you divide by 2, 50. Then this 50 you divide by 0.5. You divide by 0.5, that gives us 100. And then this 150, you divide by 0.5, and that gives us 300. That gives us 300. So we have divided these values here using the values in the key column. After you have divided, you take the smallest. The smallest is this. And that smallest becomes our key row. That's our key row. And this item here becomes the key element. That becomes the key element. And then this item here is our outgoing variable. The outgoing variable. So this S1 will go to be replaced by Y. So when I come here, instead of S1, I will now write Y, and these others will remain. These others will remain, so I have X, I have S3, I have CJ, I have ZJ, and I have DJ. And I have DJ. So when I do that, I now record the contribution margins of these three items. So the contribution margin for Y is 2,000, for X is 3,000, S3 is 0. That's the contribution margin. Contribution margin. And then what will happen? From there, I divide all the items here, using the key element. So I will start here. 2 divided by 0 is 0. 2 divided by 2 is 1. 1 divided by 2 is 0.5. 0.5 divided by 2 is minus 0.25. This is 0 and this is 50. So those ones now, they become my new row. So I need to come here and give my workings and do my workings. The workings. So the same formula we had applies. So I am looking now for his x. So I'll say odd row x value, odd row x value minus new row value, times balancing figure. Now this one should give me new row x value. New row x value. So let me start with the old row, this one. So I have 1, I have 0.5, I have 0, I have 0.25, I have 0, I have 50. Then I say minus the new row. So new row, tunaleta hizi zenye tumepata hapa. So this is 0, this is 1, this is 0.5, this is minus 0.25, this is 0, and this is 50. Then we say times. The balancing figure, I've told you, is the value at the intersection of the key column, this one, and the row that you are dealing with. So it is this one, 0.5. So that is 0.5, 0.5, 0.5, 0.5, 0.5. Then you say equals. Say equals. So you take the calc as usual and say 1 minus 0 times 0.5. That is 1. 0.5 minus 1 times 0.5 is 0. 0 minus 0.5 times 0.5 is negative 0.25. 0.25 minus 0.25 times 0.5 is 0.375. 0 minus 0 times 0.5 is 0. 50 minus 50 times 0.5 is 25. 25. Okay, so you record those values here. So this is 1, this is 0, this is negative 0.25, this is 0.375, this is 0, and that is 25. That is 25. From there, we write the formula again. We write the formula again, but now for S3. Old row S3 value minus new row value times balancing figure equals new row S3 value. S3 value. So the new row value will remain, but these others will change. So the old row S3 here, we have 0, we have 0.5, we have 0, we have negative 1.25, we have 1, and we have 150. The values in S3 here. Then for the balancing figure, it is this one again, 0.5. The value at the old row that we're dealing with and the key column. So 0.5. So we start 0 minus 0 times 0.5 is 0. 0.5 minus 1 times 0.5 is 0. 0 minus 0.5 times 0.5 is negative 0.25. Negative 1.25 minus 0.25 times 0.5 is negative 1.125. 1 minus 0 times 0.5 is 1. 150 minus 50 times 0.5 is 125. So we record them here. This is 0. This is 0. This is negative 0.25. This is negative 1.125. This is 1, and this is 125. Then CJ remains, so we are going to have 3,000, 2,000, 0, 0, 0, 0. So the other working now is for Z1. So tumesema unachukua these values here, you multiply by these ones here. So it's going to be 2,000 times 0 plus 3,000 times 1 plus 0 times 0. Huyu mwingine Z2 is 2,000 times 1 plus 3,000 times 0 plus 0 times 0. Z3, it is 2,000 times 0.5 plus 3,000 times negative 0.25 plus 0 times negative 0.25. Z4 is 2000 times negative 0.25 plus 3000 times 0.375 plus 0 times minus 1.125. Z5 is 2000 times 0 plus 3000 times 0 plus 0 times 1. Z6 is 2000 times 50 plus 3000 times 25 plus 0 times 125. So we start getting the answers. So 2000 times 0 plus 3000 times 1 equals. So that is 3000. 2000 times 1 plus 3000 times 0 plus 0 times 0 is 2000. 2000 times 0.5 plus 3000 times negative 0.25 plus 0 times negative 0.25 is 250. 2000 times negative 0.25 plus 3000 times 0.375 plus 0 times 0.125 negative is 625. 625. And then 2000, all these will be 0. And the last one is 2000 times 50 plus 3000 times 25 plus 0 times 125 is 175,000. 175,000. So DJ, we say it is CJ minus ZJ. So this will be 0, 0, minus 250 minus 625, 0 minus 175,000. Now you can see that we do not have any value that is positive here. We don't have any value that is positive. So if we do not have, then this one now becomes our final simplex table. Final simplex table. Final simplex table. So you now give the optimal results. So the interpretation of the optimal solution, So in the optimal solution, I told you the other day, we normally give 2 items. One is production. Now remember, we had a product called Alcon, which was represented by X. And we had a product known as Xenon, which was represented by Y. So what you do, you come to the final table, basis column, you look for X here. When you get it here, you go all the way to the end here. What is there are the units to be produced. So X, we will produce 25 units. X, we shall produce 25 units. And then you do the same with Y, 50 units. 50 units. So the next thing that you are supposed to tell us is the profit. And profit, they're asking for maximum. So maximum is Kenya shillings. This value that is here. Although it's appearing as positive, as negative, you write it as positive. So that is how we solve simplex. If you have any query, you can raise it. Don't seem to find another question. How comes? Okay, we can try this one of August. We can try this one of August. We shall not finish, but I can leave you at a place you can proceed with it. August 2022, question 2A. So August 2022, question 2A, we want to use Simplex method. So the first thing to do is the formulation. So the question says, TMA company produces 3 products, standard, deluxe, and luxury in 3 of its departments, which are cutting, assembly, and finishing. The total available labor hours per week for cutting are, we are given that, to produce 2 units of standard require 240 minutes, have the amount of time in the assembly department and same amount of time in finishing department as in the cutting department. Produced 1 unit of deluxe requires 60 minutes, 180 minutes, and 60 minutes in cutting. To produce 3 units of luxury requires 180 minutes in cutting and twice the amount of time in both assembly and finishing. The contribution per unit from standard, deluxe, and luxury is that. You formulate. So let's start with the formulation. We can say let S represent units of standard produced and sold. Units of standard produced and sold. And B to represent units of deluxe produced and sold. L to be units of luxury produced and sold. Produced and sold. Then objective function. Objective function is to maximize Z, which is equal to, ukiangalia hapo chini, the contribution for standard is 6, so 6S, and I hope S, let us change this S to K, so that it's not confused with 5. K, change that, K, so that it's not easily confused with 5. So 6K plus 5D plus 2L. Now subject to. Now you can see the hours that are, the time that is given in hours up there, but ikikuja kwa units we are given in minutes. Like we did in the last lesson, we converted the hours to minutes. Now this one we can convert these minutes to hours. So when we are told to produce 2 units of standard minutes, we require 240 minutes. So if you take 240 divided by 2, that gives you 120. So 1 unit requires 120 minutes. And 120 minutes, when you divide by 60, those are 2 hours. Those are 2 hours. So 1 unit is taking 2 hours. So 2K. And we are told that is in cutting. Half the amount of time taken in the assembly. So this is half of the time we take in the assembly. So assembly then must be double of that, 4K. And same amount in finishing. So this is 2K in finishing. So plus. To produce 1 unit of deluxe requires 60 minutes. So 60 minutes in cutting, that is 1D, 1 hour. 1/8 minutes, those are 3 hours. So 3D. And 60 in cutting, that is 1. Plus. To produce 3 units of luxury, we require 1/8. 1/8, those are 3 hours for 3 units. So that means 1 unit is 1 hour in cutting department and twice the amount in both. So twice the amount, so this is 2L and 2L here in both assembly and finishing. Now this one should be less than or equal to, the hours in cutting, they are 180. So this is in cutting. And then we have 300. This is in huyu mwingine anaitwa after cutting we go to assembly. And then this is 240. We go to finishing. And obviously we have been saying KDL is greater than or equal to 0. This is non-negativity. So after that, I have told you what we do is you change the inequalities. So changing inequalities to equalities. Changing inequalities to equalities. So you say let S1 to be the slack variable for cutting. S2 to be the slack variable for assembly. S3 to be the slack variable for finishing. Then you say then, sasa unarudi hapa juu, au unaendelea tu, maana have to come here. Then objective function. Mpaka here to avoid the friction. Then objective function nimekwambia unaleta hii, it is to maximize that which is 6K plus 5D plus 2L plus 0S1 plus 0S2 plus 0S3. So you bring these S's now with contribution margins of zeros. Now this is subject to you bring this one 2K plus 1B plus 1L plus 1S1 is equal to 180. You bring this other one 4K plus 3D plus 2L plus 1S2 is 300. And then 2K plus 1D plus 2L plus 1S3 is equals to 240. So that is how we do the changing of inequalities. So I want us now to draw the initial simplex table. So we are now drawing initial simplex table. Initial simplex table. So in the initial simplex table, I've told you we always have A and C. Then we have bases. And bases, I've told you we bring the S's. So S1, S2, S3. Then we have ZJ, ZJ, and DJ. That way. Then you bring now these others. So we have K, we have B, we have L, we have S1, we have S2, we have S3, we have BR. In case there will be need to create ratio. Are we up to that point?
Yes.
Good. So these ones, we are saying they attract zeros, their contribution margins are zeros. Then when you come to this S1, you bring the items which are here in S1. So we have 2, we have 1, we have 1, we have 1. We don't have S2 there, we don't have S3, but the last value is 180. Then I come to S2. I have 4, I have 3, I have 2, I don't have S1, but I have S2, which is 1. This is 0, and this is 300. Then S3, I have 2, 1, 2, 0, 0, 1, and 2, 4, 0. CJ, I told you we bring these coefficients that are here. So it is 6, 5, 2, 0, 0, 0, 0. And ZJ, because we are multiplying these values with these ones, in the first table it is always zeros. In the first table it is always zeros. And then the DJ is CJ minus ZJ, so 6 minus 0 is 6. This is 5, this is 2, 0, 0, 0, 0. So with that, you identify the highest positive because there are several positives. So this one becomes your key column. It becomes the key column. Yes. So this value here, I have told you, is called the incoming. This is the incoming variable. The incoming variable. Then for the ratio, you now come and divide these ones with the values in the key column. Like now, this will be 180 divided by 2, that is 90. This will be 300, you divide by 4, that is 75. This will be 240, you divide by 2, that is 120. 120. So you take the smallest. So this now becomes our key row. You take the smallest, which becomes our key row. And then this element here, at the intersection, tukasema inaitwa the key element. The key element. And then this one here, tukasema inaitwa the outgoing. The outgoing variable. The outgoing variable. Yeah, I can see I have 5 minutes. So I don't know whether it will be possible to design that. Let me try. So we quickly design the next table. We are designing the second Simplex table. The second Simplex table. Now, this second Simplex table, we have C here. Then we have bases. And bases is followed by K. So we have K, we have D, we have L, S1, S2, S3, I, and then we have ratio. Ratio. So I told you bases, this K, which is the incoming, will come to replace this S2. So S1 remains, but S2 is replaced by K. S3 remains. Then we have CJ, ZJ, and DJ. So S2 has been replaced by K. Then you put the contribution margin. This is 0, K has 6, S3 has 0. Has 0. So what you do next now is you divide these values in S2 using the key element, 4. So 4 divided by 4 is 1. 3 divided by 4 is 0.75. 2 is 0.5. This is 0. This is 0.25. This is 0. And this is 75. That is 75. Let us put CJ. CJ, let me assist you with CJ. CJ will remain. So CJ is 5, no, 6, 5. This is 2. These are zeros. So what we will need to do, I can see it's time, but maybe we can do one. Mike can help you to design for S1. So for S1, utakuja hapa down there iseme workings. For the workings, so utachukua odd row S1 value minus new row value times balancing figure it will give you new row S1 value. New row S1 value. So the odd row S1 values, narudi hapa kwa hii table. So I have 2, 1, 1, 1, 0, 0, 180. Those are the odd row. Then you take this new row, this one. 0.75, 0.5, 0.25, 0, and then 75. And then 75. Then you say times. Times the balancing figure. Balancing figure is the value and the key column and the row that you're dealing with. This one. So that is 2. So unaweka 2, 2, 2, 2, 2. So I believe from there you will be able to continue and finish. And when you have finished, your answers will be the table that is here. This table that is here is what you have. It's only that this table hawajaweka CJ and DJ, wameweka tu ZJ, Z to present DJ. So we call it a day at that point. We are through with that bit of linear programming. So make sure you revise. I'm going to send you some notes for the next agenda, which we shall discuss tomorrow, which is called sampling theory. Thank you.